Welcome to our new video. My name is Pavel Savianko, and today I will show you how one swaps the dimensions in the CubeGUI and for what it is useful. So we are back into our terminal where we have installed Cube. Cube is available under the command Cube, which we execute. We get our CubeGUI start screen. We select our example, trace CubeX, and we get usual three panels with the threes that is usual display for the CubeGUI with various performance values. How these values to interpret, what do they mean, one can learn in another tutorials from our partner channel, PopHPC. The link to its video I will post either here or in the description. Here we are interested only in the display of this dimension of the metric tree dimension called tree dimension system tree. So we have our casual trees, and this display works actually pretty simple. Coming from right to the left, we have generalization. So basically, every value in a panel, for example, in a call tree, corresponds to the entire dimension displayed on the right side of it. So in this case, value to Adi corresponds to the whole system tree, or to the whole system, which is displayed to the right side of it. The whole means aggregated over the whole dimensions. And if we're looking at the metric tree, it is on the most left side, so it corresponds to the entire call tree over the entire system tree. It is translated into, it corresponds to the entire execution of the application on entire system, on the whole system. So basically aggregated or summed up the values over all system ranks, over all call passes in a call tree. Coming from left to right, we have specialization. So basically the values in a panel, for example, in a call tree in this case, they correspond to the selected element in the panel, which is displayed to the left side of it. So all values in the call tree, they correspond now to the metric time because it is selected metric time. And all values in the system tree, now for example here, they correspond to the selected call pass to the selected metric. So the value 479,6 and so on of MPI rank 0 corresponds to the call pass ADI and to the metric time. If we select metric visits and another call pass, the values they change, and we see the value, for example, 20. If one asks ourselves, for example, which values do I have for the metric time on a rank 0? One didn't specify actually call pass. So in this display, what one would have? One would have to do. One would have to select the metric visits. One selects the metric call pass MPI rank 0, and one selects one by one in the call tree every call pass and inspects the selected value in the system tree. So that would be 1, that would be 8, that would be again 1, that would be again 1, that would be 2, and so on and so on. For ADI that would be 2 million something. That is of course absolutely not practical, and by typical size of the call tree of tens of thousands of calls, it's actually not possible to do. So exactly for this situation we offer swapping order of dimension. One goes into the menu display, one has here menu dimension order, and if one clicks, one gets 6 possible permutations of dimensions, and one has to bring to the right side the least specified dimension. So in our case, that would be call tree. So we can take a selection metric, system tree, and call tree, and display it like that. So in this case, we select visit, we select MPI rank, and we see at once all values for this selection in a call tree. If we select, for example, metric time, we select metric MPI rank 3, we see the all times which MPI rank spent in every call pass. So in this way, it is way easier to inspect the values. If we ask ourselves, for example, which values which metrics did I collect for the call pass xsolve, for example, for the MPI rank 7, for example. So in this case, I would have to select xsolve MPI rank 7 and select every metric one by one and inspect its value in the most right panel. Or we can do it better. We go into the menu display, we go to dimension order, and we bring to the most right side the least specified panel. In this case, it is metric, and for example, we can choose either call tree system or metric, or system call metric. Let's go for this one. And here we can select xsolve, our call pass of interest. We select MPI rank 7, or our rank of interest, and we see the metrics values. And these values, they correspond to this selection. So we know that MPI rank 7 spent in xsolve call pass 170 seconds. There were 658 something thousand visits, and so on and so on. One can ask oneself why here are zeros. That is simple due to the fact that metrics, one cannot adapt the metrics. Or coming to the beginning of this video, the values in some tree, they correspond to the entire tree or entire dimension which is located on the right side. And in this case, it's entire metric dimension, but the metric dimension one cannot add up. So here are seconds, here are occurrences, here are bytes. One cannot add it up. Therefore, there is no value which can be displayed here meaningfully, and therefore we display here nothing. And in this configuration, the trees they play only role as a selector. So we can select here MPI rank, we can select here call pass, and we get here some values. Some hybrid situation we get if we get a metric tree in the middle. So for example, if we go into display system metric call, like this, so we can select some rank in the system tree. Again, it is on the left side of the metric tree, so one cannot add up all values from this matrix. Therefore, here we display nothing, and here we can display something, and this something is the all values which correspond to the metric bytes transferred for the MPI rank 2. If we click on time, then we see all the values in a whole call tree for the metric time for the MPI rank 2. And in this way one can analyze performance data in much more comfortable way. I hope you liked this video. Please comment, subscribe, and give us a like. Thank you very much, and see you next time.